Hello CIS18A. This is part 3 of week 4 lecture, which covers inheritance and also abstract classes. So this is chapter 7 in the textbook, and I want to touch on inheritance and emphasize inheritance in that this is part of the project requirement, and also it's very important that you understand this moving forward as you improve your skills in Java programming. So there are 3 foundation principles that we need to discuss in inheritance. Usually you would have a general class which really define a common set of traits, or the contain members which contains the properties of that particular class. So then you would have a subclass which is a child of that class, and it would inherit some of the traits and from the version of the superclass. So just think about like an analogy is a family structure where you would have a parent that would have dark hair and dark eyes, and the child of that parent might inherit the trait of the color of the hair would be dark hair. So inheritance in Java classes, we can have it inherit all the variables and the methods from the parent class or the superclass. So if the parent contains, let's say, 3 variables and 3 methods, we can have the child inherit all 3 variables and 3 methods. You can also have it inherit specifically, less variable or all the variables, or we can add in a unique element in the child that's going to be different than the parent. So going back to the example earlier, I mentioned that the parent might have dark hair and dark eye. We can have the child as having dark hair but lighter color eyes. So the subclass would inherit some of the traits or all of the traits, where the superclass also would have different unique traits or same as the traits with the child. So with the inheritance, you can allow one class to incorporate another class in its declaration. So the subclass, all you're going to do is you're going to extend it from the superclass. So let's think about it. Your parent and have you, and you are an extension to your parents' family. So we would use extends as the subclass is added to the superclass. So here in this example, if it's quite small, you can enlarge it by stretching it out and look at it. So in this example, we have the first class, which is toShape. And toShape has 2 instance variable, width and height. And it has 1 method, showDim. In the second class, we have class triangle. How do we know it's a subclass? It's used extends from toShape. So it would say extends and the parent class. So if you have a subclass, you can extend from the main parent class. And in here, we would have string style is its own instance variable, double area. And then we wanted to inherit the width and the height and bring that for calculation here to get the dimension of the triangle. So, and then show style is the child or the subclass own method. Then next, what we have is we have class shape, which is the third class, and this class contains the main method. And in the main method, like all the other example we looked at, we have object, we construct object T1, T2. We would use T1 to access the attribute from the parent class, which is width, height, and the attribute from the child class, which is style. And then we use the second object and we do the same thing, access the the members of the parents, which is width and height, and then one of the member is in the child is style, and that would be used for the second and the first object. So also we can use it to the object to access the method, and the first method is show style, and recall that show style is in the child or the subclass, and show dim is in the parent class. So you can, because it inherits, you are able to access the parent and the child. So we wanted to use the extend as the way that we can extend from the parent class to the child class, or from the superclass to the subclass. And so as you can see, it is simple, but this elevates our programming skill to the next level. We've been talking about using multiple classes. We talked about, in part 1, we talked about using public and private to control the members in each of the class. But in this case, we can also allow access of members and member method from one class to another by extending it, saying that there's a superclass and that will be extended to the subclass. So this example shows you on how to be able to implement that. Now, simply we would start with the class declaration, and if you wanted to have the inheritance, you simply would use extends and then the superclass name as it's structured in general form here, or you can look at the example. One of the important things to look at and think about and know is Java does not support inheritance in multiple superclasses to a single subclass. So in other languages, we might have multiple parents to one child. It does not work like that in Java. You cannot have two parents to one child, as it doesn't support the inheritance of the multiple superclass to one single subclass. But to create the hierarchy in this for the subclass, in which becomes the superclass in another subclass. So what we can do is we can have that child is a superclass of the grandchild. So we would be able to carry down the inheritance to the third generation or the third level. So if there's no class that can be a superclass itself, so in that way, when you make the child become a superclass, then truly when we're looking at the hierarchy in the inheritance of the subclass becoming a superclass of another subclass in 3 level or more, then we really don't have a true superclass. So now when the advantage of inheritance is that you can use the attributes and carry that attributes using the object down to the subclasses, having not to have to recreate those attributes. You can reuse the members and the method, and so that way it can be used to create more specific areas of the subclass, or could be a little bit different than the superclass. So in the example here, it shows that there's a subclass of the 2D shape of the rectangle. How do we know it's a subclass? Because this is the class name, the subclass name, rectangle, and it's an extension of the superclass, which is 2D shape. And that's how you can tell because of the extent. So when I grade the project, I'm going to start looking for that to see if you implement inheritance. And the way that we would do that in Java is using extent. and using object to access various members of the member method. So let's touch back on member access and inheritance. And in instance variable, if the class is only declared to, if you use private, it would be only allowed to be used inside that class. And if you want that member to not be utilized outside of that class, you would use the specifier private. Thus, even when the subclass includes all the members of the superclass, if the one of the members is private, it cannot access it. So to prevent access, you can have, a member that would be private, then the value that's stored in that member will not be accessed. The attributes will not be accessed because that member is specified to be private. So here in this example, what we have is we have two private members, double width, double is the type, width and height. And then we have a method show dim. Now what we in the next part, we know that the class triangle is an extension of the superclass 2D shape. And in the next part, we're trying to bring down the width and the height for the calculation of the area, but it's not able to access that. It's going to throw an error because these specifier are used, private. Now, if these are public or they are not specified, which is considered public, then it is accessible. But if it's private is specified here, it's no longer accessible. They're both no longer accessible. Okay? So to touch back, and that was covered in the earlier videos and chapter 6. So also here, it also shows how you can access method. So when you return, right, value for width and height, the accessor method is for width and height. So that when you, after it's returned, it's going to bring the height value and plug it into here in the subclass, in the child class, which is triangle. And so with the get height, it's going to return the height. It's going to plug the height into here. So now for the set height, in the third class, when we call the set height and the set width, that's going to come back to that particular method when it calls on that method. But for the get height, because the get height is being used and the get width is being used in the subclass, it's still going to be able to bring it down as these methods are not private. Okay, now earlier we talked about the width and the height members are private, but the methods are not private. The members are private. It will be able to set it inside that class, and once we get it and return it, it's going to bring that over to the subclass. So there are ways that we can be able to produce the value by using the method, and that method is accessing that locally private member and returning the value, using that value in the subclass by calling the method. So here what you see is that we are still be able to access the instance variable since the method is defined within the superclass. It's even though it's made private, and then once it's returned, it's going to only be available through the accessor method. So we would use the accessor method to bring down the value into the subclass, as the child class is the extension of the superclass. Okay, so let's talk about constructors and inheritance. So it's possible that you can have different constructors. So how are we able to inherit the constructor? So the constructor for the superclass construct the superclass portion of the object. The constructor for the subclass construct the subclass of the object. The construction must be separate. Most classes have explicit constructor. Only the subclass defines a constructor, and the superclass portion of the object is constructed automatically using the default constructor. So now translating that to Java, here's the example. You have the superclass 2D shape. Just like the previous example, we have the private, double, width. These members are private, width and height. We have accessor method to be able to return the width and the height. And then we want to be able to calculate the width and the height in the next class, which is the child class. Now, in the subclass, here we have to initialize the portion of the object, W and H. Okay? And within this, what you have is you would use the object to be able to show the actual dimension of the triangle. So now with the H and the W here, this is the portion of the object, and its constructor is set width and set height. Okay. Now with the third class, when you construct T1, T2, that is a different constructor, even though it's from it is an object of the triangle, and it's constructed the object for the triangle and how we would be able to implement the values there. But when we call the method for T1 and T2, notice that in the main here, for T1, we're going to bring down the show style, which is in the subclass, and show dim, which is in the parent class or the superclass. So the constructor for the subclass is different than the superclass, in that it's set width here and set height is being used. But when we construct, we have to explicitly construct for T1 and T2 in the third class in order to access the methods from the super and the subclass, as what we see here in the objects are coming from triangle, which is the child class, and we're accessing the member method from the parent and the child class. So now both the superclass and the subclass constructor must be executed, and it must be used super in the case that it is a superclass. So for the superclass constructor, it needs to use the keyword super. Now the second access member for the superclass is hidden from the member. So here is how we would use the keyword super. So this is the constructor for the superclass. So we created the constructor for the 2D shape here. And for the subclass, since it is a subclass, you would use the super method superconstructor, to be able to implement the W and the H object in the subclass. So this is how you would be able to implement the 2D shape constructor into the subclass. Okay, using superconstructor. And that's a little bit different than the last one, in that the last one we simply create the object, and then we'll be able to use the object and then access the attributes. But in this one, we actually using the superconstructor to be able to access the object that was previously constructed in the superclass. So here it should also give you another example on how you can use super to access superclass members. So you simply use the dot operator. We would have super dot member. So in this case, we would have super dot I, and I came from class A. In class B is a subclass of class A. So you would use super dot member to be able to access the member, or that could be member method or instance variable. So in multi-level hierarchy, it is acceptable to use a subclass as a superclass of another. We talked previously about 3 generation, the parent, the child, and the grandchild, where the child is the superclass of the grandchild. So this is an example of the multi-level hierarchy, where 2D shape is the superclass of triangle, and triangle would be a superclass of another class. So with the triangle, you would have various things like default constructor. You would be able to call the superclass using the superconstructor here and be able to use the argument constructor. Now in the next class, color triangle, it is the third class. That's going to be the grandchild. It extends from the triangle. So with Java, you can have multi-level hierarchy like this, and you can have more than 3. You can continue on as you get deeper and deeper. And so what happens is that color triangle is the descendant of 2D shape as it inherits from triangle, and triangle inherits from 2D shape. It's like the grandchild is the descendant of the grandparent because the grandchild inherits the traits from the parent. So this provides a longer example, but it shows you how multi-level inheritance is used, and how we can use methods or members variable. So in all illustrations thus far, we see that whether it's single level or multi-level inheritance, what we have is we have super as we would use that as the constructor for the closest superclass, the previous class. That's going to be the superclass. And in the case of color triangle in the example, when we use the superconstructor, it calls the constructor from the triangle. And in the triangle subclass, when we use super there, it calls for the constructor from the 2D shape, and so forth. So now one of the question that comes up is it says when the subclass object is created whose constructor is executed first, the one subclass is defined by the superclass. If the given subclass called B and the superclass called A constructor executed before B, or vice versa. So the class hierarchy constructor complete the execution in order to have derivation from the superclass to the subclass. Since super must be the first statement executed in the subclass constructor, this order is the same whether or not super is used. If super is not used, the default parameterless constructor for each of the subclass must be executed. So that means that the constructor, in this case we're using super constructor, that would be the first executed under the subclass constructor in order for, and that would be in that order subsequently. And if we don't use super in the subclass, then what happened is the parameterless constructor would then be executed. So looking at this example, we have class A. This is the constructor for A. Class B is a subclass of class A, as we use extend here, constructor for B. And class C is a subclass of class B, and we use a constructor there. So now, when we have the main, we have the object C is type of class C. It's constructed for class C. And so in this case, the constructors are executed in order of derivation. It's going to go A, B, and C. And so because in order to have the inheritance from B, it needs to execute the A in order to bring down the inheritance to B, and from B to C, and so forth. So because we didn't use super in this case, it's simply just execute the parameterless constructor, which is what you see with A, B, C with the parentheses there. So the superclass has no knowledge of the subclass, and so any initialization needs to perform separately and possibly as a prerequisite for any initialization performed in the subclass. So it doesn't have any knowledge that there is a subclass, so it needs to initialize that first in order to be able to have the initialization of any of the subsequent subclass. In following, we have the superclass references and the subclass object. And so here, please note that type compatibility is very important. It's strictly enforced. So a reference variable of one class type cannot normally refer to an object of another class type. So this example, we have class A, we have the instance, or class X, we have the instance A. X becomes the type, and we have int I. Now class Y, we also have int A, Y becomes the type. Now there's incompatibility in the reference in that we have X object of X type, so the X object is constructed, and X2, Y is constructed, and so we would say X2 is equal to X and X2 is equal to Y. It is incompatible where X2 is equal to Y because the types are different. So it has to be the same type, and that's important to note. So when you reassign a reference like this, they have to be the same type between the superclass and the subclass object. And so when you run into issue when it's throwing error, you have to take a look at the type, how the type is used. And so important to note that an object reference variable can only refer to the object of its own type, its type. Now a reference variable of a superclass can be assigned a reference to an object of any subclass derived from the superclass. So hence, that means that the superclass reference can only refer to the subclass object. So The following example shows you how superclass reference can refer to the subclass object. So we have class X, and class X is the superclass, class Y is a subclass. We have the instance A, instance B for Y, A for X. Then here, because Y is a subclass, we would have the super constructor here for J, and we would reference B is I because it's B is the instance for Y. So in the main, we're constructing X, and then we have X2 as type X. We'll construct Y, and X is equal to X. That's okay because they're the same type. X is equal to Y. It's still okay because Y is derived from X. It extends from X. And because there's direct inheritance, so we would have X2 A. So we're accessing A for X2 and B. So here what we still gonna be okay for A as it brings down the 19, but because B, when we look at B is referencing I, and X doesn't have the same B member, so it would throw an error. Okay, because B is reassigned to I, and B doesn't have the same member, so it's gonna throw an error there. So it is important, as noted here, that the type reference variable, not the type of the object that is refers to, it determines what members can be accessed. So in reference, the subclass object is assigned to the superclass reference variable. You will not be able to access other part, only able to access the parts that are defined by the superclass. So now on the next part, it talks about overriding methods, and it goes into dynamic method dispatch. So the dynamic method dispatch is a mechanism to call an overriding method. And dynamic method dispatch is important because this is how Java can implement runtime polymorphism. For this, when we're working with the class inheritance, we would see that the superclass reference the variable and refer to the subclass object. So when an overridden method is called, the superclass reference, Java determines the version that the method executes based upon the type of the object referred to at the time of the call. So that means that would determine all of that determination is happening in during runtime. So now the example for the dynamic method dispatch is as follows. So we have class sup, and we have a method called who, and sup1 is an extension of sup, so this is a child class or the subclass. We're also using the same method who, we're calling the same method, so we're overriding the method there. Now in the main, we construct super OB, sub OB1, and sub OB2. These are objects. And with this, we would be able to overload the method, and in this case, overriding the method. So when we're calling who here, we're actually using the subref in each of the case who is called, and that will be determined at the runtime the type of the object being used. So we can repeatedly use for, so we would reference subref as superop, subref as subop1, subref as subop2, and we would continue to call who there under subref. So this is considered the overwritten of method as the method would be called. So why would we do this? And because for object-oriented programming, it allows the general class to specify the methods and that will be common and to all of the derivatives as you would have inheritance, allowing the subclass to implement some or all of the methods from the superclass. And, going back to the terminology or the phrase that we heard earlier, one interface, multiple methods. That way we'll be able to reuse the methods that was defined in the superclass in the subclass, and that provides all the elements from the superclass to the subclass through the inheritance. So with the inheritance and overwritten method, the superclass would have the methods that can be used by all of its subclass. So that way we look at how that would be reusing throughout the program, or we would say overriding throughout the program, where it would make it flexible and also efficient. Next, we're going to talk about abstract method and abstract type modifier. So abstract method has no body. It's not implemented by the superclass, but in the subclass must override it. So you would use abstract type and then name. So we would have abstract, the type, and then the name, and then you can include the parameter. Now the modifier, the abstract modifier, can only be used in the instance method. It cannot be applied to static methods or constructor. That's important to note. And one or more abstract methods must be declared in the class if it's abstract by preceding class in declaration. Now, if there are no objects in the abstract class, it would attempt to create the object with the abstract class by using new, or if you attempt to create the object by using new, that's going to generate the error. If it implements, it must implement all of the abstract methods in the superclass. So let's take a look at the example before we get into the final, using final, and that would wrap up. Oops. So here we have an abstract class, hence we use abstract here, the class, and then its name. We have the private members, and then we have the default constructor with no parameter. In the parameterized constructor, in the second part here, we use double W, double H, and string N. In the next part, we also construct the object using double X and then string N. So notice that we have the constructor. We change up the parameter of the constructor, so we're overloading it here, and then we're overloading it again here. Next, we would use it to construct an object from an object. So we simply use 2D shape, and then the object name. And then we would use that object to access the attributes with height and name. Then the next part is the accessor methods, where we would use get width, get height, because notice at the beginning we had private members, so we would use accessor method to be able to return the value so we can access the value from that was stored in those members. Then we would then have the abstract variable. So now, abstract method, which is double area. So this method would be the method that would be used with the abstract class. So here is your abstract method. Because recall, we have abstract 2D shape at the beginning right here. So we have to implement the abstract method, which is now abstract double area. And next we have the second class, which is the subclass of the first. Triangle is the extension of 2D shape. And here we have the default constructor triangle super. And then again, once again, we would use different parameter with the constructor. And we would construct the object within the object just like previous. And we would have the accessor method. So in this sense, what we see is that we have a subclass of a 2D shape for the triangle, and with that we would use the constructor, the default constructor, and be able to access that. So let's get to the section where we would see the abstract being used. So remember that area was the abstract method, and area was being used to calculate here. So when in the second part, what we have is when we construct the object rectangle here, which is a different class now because we went from triangle to rectangle. Now in this one with the double area, this is not an abstract. This is just an instance method where it's going to return width times height. Now this is a subclass of the previous in that it is a subclass of the 2D shape in that it is an extension of the 2D shape. So in this case, 2D shape is the parent and it has two children, triangle and rectangle. In the triangle, it has the double area, and that double area is using, it's basically the same thing continuously between the two classes. Rectangle is also using area. Now in this one, what we're bringing down here is we are constructing the object with the object, and then we'll be able to output, we would be able to use the object to access the width and the height in order to return that in the method, from the method, in order to calculate the area of the triangle and the rectangle. So now in the main, we have shapes, and the shapes is the array. So for the 0, that would be the outline, and this is we construct the object for the triangle, and then shape 1, that's going to be in the second element of that array is shape 1, and that's going to be the object for rectangle. And in the parameter, we're using the value. So ultimately, the program, all the subclasses 2D shape must override area method, and to try creating a subclass that does not override the area, you're gonna get an error. So this example shows that because we're using the abstract area in the first class, when we override it, it's gonna generate the error. So next we're going to talk about final. And so to prevent method from being overridden or a class from being inherited, we would use final. And final prevents overriding and final prevents inheritance. So if you don't want inheritance, you can put in final into a superclass or into a class. If you don't want overriding, like in the example here, you would use the keyword final. And you can also use final with members. So with the data members, you can use final and then the type and then the member name. So in this case, if you declare a final constant, it's not going to allow inheritance in the subclass. So that's how final is used in Java. And for the exam, make sure that you understand inheritance. You need to understand how subclass and superclass works, and also how final works. The last part of this covers object as a class. And it is an implicit superclass to all the other classes. So in other words, all classes is a subclass of objects. So it is the superclass, and it references variable of all type for the type of object that refer to any other object in the class. And here it provides you with a chart, a table on how you can look at the methods and the purpose under the object class. And this would conclude my part 3 of the week 4 lecture in CIS18A, in which I cover inheritance, super, constructor, accessing superclass and subclass, and also multi-level inheritance, overriding methods, looking into abstract, using final to prevent overriding and inheritance, and also a little bit on the object class. And thank you for watching my video. Please take a look at the lab videos if you're working on lab for week 4. If you have any question, please let me know.